Hello everyone. Now today we're going to learn to find out the unit outward normal vector to the surface and angle between two surfaces. Okay. Now let's look at the definition for unit outward normal. Let S be a surface. The unit outward vector to the surface is denoted by n cap or capital N, and it is defined as n cap equal to del S by mod of del S. Okay. Now del S, we know it, which is known as per gradient of S. Now in last classes we learned how to find the gradient of a function. Now that gradient we are going to use it here to find the del S. Now by magnitude of the del S to get a unit outward normal for the surface. Now here del S represents the normal. To convert as unit vector, simply divide by its magnitude. Right? Now next look at the problem. Find the unit outward normal vector of the surface x square plus y square plus z square equal to 26 at the point P of 2, 2, 3. Okay. Now the given S is x square plus y square plus z square minus 26. Now del S is del operator, differentiable operator, and here yes. Now this is we need to apply for each term. Now I dou by dou x of x square plus 2y x square plus y square plus z square minus 26. Now this derivative with respect to x square derivative is 2x. Now this derivative with respect to x is 0, y square derivative 0, z square derivative 0, 26 0. Only the deviation we have right. But this term is 2x plus z times dou by dou y of x square plus y square plus z square minus 26. Now this term derivative with respect to y is 0. Now this derivative is 2y. Now this derivative is 0, this derivative is 0. We have only 2y plus k dou by dou z. Now only one term we have z. Now the derivative is 2z. Remaining terms are 0. Okay. Now del S. Okay, we have unit normal vector at 2, 2, 3. Then del S at 2, 2, 3. Now substitute x equal to 2, y equal to 2, z equal to 3. Okay. Here 2 substitute is 2 2s are 4i plus again y equal to 2 substitute here 2 2s are 4j plus z equal 3 substitute here 6k. Now this is a normal to the surface. Yes. Now they asked to find for a unit over, right? Unit. Now this then convert as a unit vector, simply divide by its magnitude. Now del S by mod of del S. Now del S is 4i plus 4j plus 6k by root of 4 square plus 4 square plus 6 square by root of 4 square is 16 plus 4 square is 16 plus 6 square is 36. Now simplify that to get for unit outward normal to the surface. Yes is n cap equal to 4i plus 4j plus 6k by root of 68. Now this is a way to find out the unit outward normal to the surface. Yes. Now next angle between two surfaces. Okay. Now here let for F1 and F2 are two surfaces. The angle between them is cos theta equal to del F1 dot del F2 by mod of del F1 mod of del F2. Actually this formula we already learned in an intermediate standard, that to find out the angle between two vectors. There you learn cos theta equal to if you have a comma b are two vectors, then cos theta equal to a dot b by mod of a mod of b. Here we need to find out the angle between the surfaces. Now instead of to find the surfaces, simply find the angle between two normals. Okay. Now to find the angle between the surfaces should be intersect. Let's say the surface is like here like this, intersect, right? This we need to find out the tangent normal. Again for this normal we need to find out the angle between them. Okay, now like that we need to go into apply formula cos theta. Actually we are finding angle between two surfaces using of tangent also, that intermediate standard long. Here we took using of normals. Okay, now look at the problem and easy to understand it. Find the angle of intersection of the surfaces x square plus y square plus z square equal 29 and x square plus y square plus z square plus 4x minus 6y minus 8z minus 47 at the intersecting point they given 4 comma minus 3 comma 2. Now find that, simply apply the del on this to get for normal to first surfaces. Now apply the del on second one to get for normal to the second surface normal. Now find the angle between the two normals. Okay, f1 f2 del f when I applied del f1. Okay, now dou by dou x of this one is 2x, dou by dou y is 2y, dou by dou z is 2z. Okay, now at the point 4 comma minus 3 comma 2 in place of x substitute 4, y is minus 3 and z is 2. Substitute to get here 4 to say 8i, here 2 into minus 3 is minus 6a, 2 to the 4k. Okay, is del f1. Next del f2. Del f2. I dou by dou x plus j dou by dou y plus k dou by dou z x square plus y square plus z square plus 4x minus 6y minus 8z minus 47. Now dou by dou x square derivative to x. Here 4x derivative is plus 4. Remaining terms are independent of x. There is no x terms here. Simply zeros. Plus z times of y square derivative to y minus 6. Okay. Plus k into with respect to z. Z square derivative to z minus 8. Here remaining terms are 0. Now substitute the point 4 comma minus 3 comma 2. Then here 4 to say 8 plus 4 is 12. Now minus 3 minus 6 minus 6 minus 12. Okay, here 2 to the 4 minus 8 is minus 4. Okay, 12i minus 12j minus 4k. Okay, now is a del f1 at this point in point of intersection, del f2 at the point of intersection. Now del f1 del f2, then use a cos theta formula in between these two vectors. Now the formula we have cos theta equal to del f1 dot del f2 by mod of del f1 mod of del f2. Now 8i minus 6a plus 4k dot 12i minus 12j minus 4k by magnitude of first vector 8 square plus 6 minus 6 square plus 4 square dot root of 12 square plus minus 12 square plus minus 4 square. Okay, now dot product 8 12 are 96. Minus 6 into minus 12 is plus 72. Minus 4 into plus 4 into minus 4 is minus 16. Okay, now that simplified it for cos theta equal to 152 by root 116 root 304. Now theta equal to, now the cos will come here. Now cos inverse of 152 by root 116 root 304. Now this is a way to find out the angle between two surfaces. Okay, now next some important one, some different problem on the angle between two surfaces. Find the value of a and b so that the surfaces ax square minus byz equal to a plus 2 into x and 4x square y plus z cube equal to 4 may intersect orthogonally at the point 1 comma minus 1 comma 2. Now here two curves. Now first curve and second curve, they are intersecting the point of 1 comma minus 1 comma 2. The intersection is at orthogonal. Orthogonal nothing but perpendicular. Now they are intersecting at perpendicularness, right? Now angle between these is 90 degree. Perpendicular nothing but 90 degree. Okay. Now f1 f2 given. Now we are no need to find out the angle they given 90 degree. Now we need to find out a comma b values. Okay, but we use the formula that cos theta, but they use theta is in 90 degrees. Okay, now they are going to use it here. Now cos theta equal to del f1 dot del f2 by mod of del f1 mod of del f2. Now theta is 90, right? Therefore cos 90 is 0. Apply for 0 LHS side, then we have del f1 dot del f2 is 0. Simply this condition we already know it in intermediate, that you learn the two vectors are perpendicular, simply their dot product equal to 0. Here two surfaces are perpendicular, nothing but their normals also perpendicular. What is the normal of our first curve? Del f1. Okay. Now second curve normal del f2. Okay. Now their dot product should be 0. Why? Is a perpendicular, right? Simply apply del f1 and del f2. Now the dot product make it 0. Okay. Now that is equation number 1. Use this condition to get for a comma b. Now find for del f1 here. Now del and f1. Now dou by dou x, here ax square, x square derivative is 2x, now 2ax, this term 0, there is no x term here. Now this term derivative is a plus 2, minus half a plus 2, x derivative 1 is minus half a plus 2, plus j into, now dou by dou y term, this 0, only this term derivative with respect to y, derivative 1, we have minus bz, okay, plus k into dou by dou z of z term, this term 0, only this term derivative with respect to z is minus by. Okay. Now del f1 at 1 comma minus 1 comma 2, substitute the point, then we have a minus 2 into I minus 2bj plus bk, equation number 2. Now next similarly find the del on f2. Now del and f2. Now I into dou by dou x, here 2x, 2 into 4 is 8xy, j into dou by dou y is 4x square, plus k into dou by dou z, 3z square. Okay. Here the point 1 comma minus 1 comma 2. Now I into x place 1 and y is minus 1 and z is 2, substitute it. Here you can get minus 8i plus 4j plus 12k is equation number 3. Now is del f1, del f2. Okay. Now these dot product becomes 0. Now use the condition that for 3. Now using of 2 comma 3 in equation number 1. Okay. That is the dot product is 0. Dot product a minus 2 into minus 8. Now dot product apply it. Now you can get it here minus 8 into a minus 2 plus minus 12b into 4 and b into 12 equal to 0. Simplify it to get 2a minus b minus 4 equal to 0. That is equation number A. To get a comma b, you get two values, you should be have two equations. But you use the condition that del f1 del f2 equal to 0, we have only one equation. We required other equation to get a comma b values. Okay. To get that, simply when you look at the problem again, the two curves are intersect at the point minus 1 comma minus 1 comma 2. Okay. Now these points should be satisfied by the two curves. Okay. To get other equation in terms of a comma b, I simply substitute these point on the first equation. You may have the doubts are, if you apply for the point on the second equation, second curve, what happens? Simply it's satisfied, but there is no use of getting the equation in terms of a comma b. To get a equation of in terms of a comma b, simply I substitute these point 1 comma minus 1 comma 2 in the first equation or first curve. Okay, that I do it here. Substitute 1 comma minus 1 comma 2 in f1, then now x equal 1, y equal minus 1, z equal to substitute to have the relation that b equal to 1. Now this b equal 1 substitute in a. Okay, substitute b equal 1 in equation number a to get for a value minus a equal to 5 by 2. Now the two curves are intersect orthogonally. You can get one equation. Use the condition of del f1 or del f2 equal to 0. Then the point substitute the curve equation where the curve having for a comma b values, get for the relation. Now using the equation to get for a comma b values, a equal to 5/2 and b equal to 1. Okay. Now some of the homework problems are given for a practice nice. Okay. Now these problems are due as a homework problems. Okay. Now next class I am going to introduce direction derivative. Okay, direction derivative. Thank you.